Hi guys, welcome to our channel Helm of Science. I am Shodan and I'll be starting the chapter light with you guys. So light is a very important chapter for your boards level. It's like one of the chapters where most of the questions are asked. So it's quite a huge chapter and there are many topics which have to be covered. So it may take few sessions to complete this chapter so that you guys learn it properly, understand all the details and do well in your exams. So I'll start with the basics of light. So what do you mean by light? uh, so light is actually a form of energy. It's a form of energy. It's a form of energy which helps us to see objects around us. It gives us the sensation of vision. So it helps us to see objects around us. So let's take an example. Let's say there is a source of light. It may very well be a tube light in your room. So the light rays from the tube light falls on any object and it gets reflected from them and enters our eyes, so that we can see those objects. So light rays falls on objects and gets reflected and enters our eyes, so we are able to see objects around us. So the next question comes, that is, what is the source of light? A source of light is basically an object which emits light energy. So a source of light can be a tube light, maybe a bulb. Now there are two types of sources of light. Source of light. Now there are two types. Luminous object and a non-luminous object. So what do you mean by luminous? Luminous sources are those sources which have the ability to produce light energy on their own. So it may be the sun, stars, tube light, bulb. These are all sources which can produce light energy on their own. But however, the non-luminous sources are those sources which reflect the light produced by the luminous ones and scatter them so that we can see them. So non-luminous sources, the examples are anything. It can be anything. We know the moon does not have lights on its own. It reflects the light from the sun. It can be anything. A table, chair, anything can be a non-luminous source. Anything which we see around us is a non-luminous source unless and until it doesn't produce its own light. Now if we consider a flashlight, a torch, if we consider it as a torch, what do we observe is that light rays always travels in a straight line. Light doesn't travel in a curved motion. No, it doesn't travel. It always travels in straight lines. This is one of the properties of light rays, is that light rays always travel in straight lines. Now, so this single rays, and for light rays we have to give arrow. So for single rays, this is a light ray and it always travels in a straight lines. If we consider a bunch of these light rays, this is known as a beam of light. A bunch of light rays together form a beam of light. Now we'll come to the new topic, what is the medium of light? Medium of light propagation. What do we mean by the medium of propagation of light? It means the medium through which light actually travels. So there are three mediums of propagations of light, that is a translucent, sorry, let's start with the transparent one. Transparent medium. Transparent medium is that through which light propagates fully. Like transparent objects are those objects which allows all of the light energy to pass through them. They allow light energy to pass through completely. They allow light energy to pass through completely. So examples are air, water, glass, and so on. These objects allow light energy to pass through them completely. Next comes translucent medium. Translucent. These objects allow light to pass through them partially. They allow light to pass through them partially. Now, what can be the example of a translucent body on an object? It can be paper. Paper allows only partial light to flow through it, and it can be frosted glass. Only a portion of the light which passes through it gets through it. So now we'll move on to the next medium, which is an opaque one. Opaque medium. Opaque body is one which doesn't allow light energy to pass through it. It reflects the light rays which are falling on it rather than letting it pass through it. So it doesn't allow light to pass through it. Does not allow light energy to pass through it. Examples are any of like wood, metals. These are opaque bodies which doesn't allow light to pass through it. Now, these are few of the basic concepts which are related to light, and these basic concepts you needed to know. So let's consider a scenario. Let's say this is a mirror. Let's say this is a mirror and you are standing in front of it. Let's say this is a source of light. It may be a tube light or anything. Light rays fall on you. They fall on you, gets reflected from you. They get reflected from you and again reaches back to us and reaches our eyes. So from source of light, the rays fall on us, they get reflected and falls on the mirror. This is the mirror, and from reflection on the mirror it reaches our eyes again, and so we are able to see ourselves if we stand in front of a mirror. So what happens is that if this was a glass door, we know we can see through a glass door, right? So what is the difference between a plain mirror and a glass door? Glass door is transparent and we can see through it, but however in case of mirrors they have a silver polishing. They have silver polish which reflects 98% of the light rays falling on it. So the silver polish which mirrors have, they does not allow the light to pass through it and hence makes them opaque. So now we will start with the first concept of light here. These were all the basic parts, so we'll start with one of the most major part of the chapter light, which is reflection of light. reflection of light. Now, so far I have discussed that when light rays from a source like fall on an object, it gets reflected, right? And which falls on the light rays which are reflected from any object, which enters through our eyes, and we are able to see those objects. So what do we mean by reflection? Basically, when light rays falls on an object or a surface and bounces back into the same medium, that is known as reflection of light. So when light rays fall on an opaque or polished surface, it gets reflected back into the same medium. This phenomenon is known as reflection of light. The bouncing of light from an opaque object into the same medium is known as reflection of light. So now if we take an example, let's say this is an opaque mirror, this is the polished surface. So light rays fall on this mirror. Let's say this is a light ray, and we have to give arrows. In case of any ray diagram, we have to denote it by arrows, or else it becomes worthless. Ray diagrams without any arrows becomes worthless because they are merely some lines drawn on the paper. So because of this arrow, we get to know that this ray is traveling in this direction. So you have to keep in mind that in case of any ray diagram, if you miss the arrows, it is worthless and you will not get your marks in your exam. So you have to denote it by arrows. So a light ray which falls on this polished surface gets reflected back into the same medium. So when it was coming from, let's say it is air. So it was coming through air and it falls on this opaque surface and it gets reflected back into the same medium. So what happens is, this phenomenon is known as reflection of light. Light rays bounces off from the opaque surface. So now we'll come to the next part, which is the laws of reflection. Laws of refraction. Now before I come to the laws of reflection, we'll cover two parts, like types of reflection. Types of reflection. Now there are two types of reflection. One is regular, the second one is irregular. Now what do we mean by regular reflection? If we go back to the previous scenario, this is a plane and a polished surface, and this surface is quite even and it's polished, and light ray falls on it and it gets reflected. If another parallel ray falls on it, these two light rays are parallel, so the reflected ray will also be parallel to the reflected ray of the other one. So when two parallel rays, or when parallel rays fall on an polished and an opaque surface, an even surface, the reflected rays are also parallel in nature. So this is known as regular reflection. When a set of beam of parallel rays fall on a opaque or an even polished surface, the reflected rays are also parallel in nature. Now if we come to irregular reflection, what happens is that the surface is not polished and it is not even, rather it is uneven. There are bumps in the surface. So what happens is that when parallel rays fall on the uneven surface, when parallel rays falls on the uneven surface, they get reflected back in in every direction possible. They are not parallel, and they get reflected in random directions. Okay, so this is irregular reflection. So now we'll move on to the laws of reflection. What do you mean by the laws of reflection? Now, this is the polished surface. The light ray falls on it. Mind you, this is regular reflection, and after striking this polished surface, it gets reflected back. So we need to keep in mind few terminologies. The ray of light which falls on the opaque object, this ray is known as the reflected ray. Sorry. The ray which falls on the opaque surface is known as the incident ray. It is known as the incident ray. And the ray which gets reflected from the opaque surface and it is reflected back, this ray is known as the reflected ray. So the ray of light which falls on the surface is known as the incident one, and the one which is the reflected is known as the reflected ray. Let us consider the point of contact of the incident ray on the opaque surface as O. If we draw a perpendicular line which is perpendicular to this point O and the surface of the opaque mirror, if we draw a line, this perpendicular line is known as the normal and is denoted by N. We draw a perpendicular line to the surface and at the point of contact, it is known as normal and is denoted by N. Let us denote this incident ray, starting of incident as A and the reflected ray as B. There are two laws of reflection. So the first law of reflection, states that the incident ray, the reflected ray and the normal at the point of contact O lies on the same plane. I'll write it down first and then explain. The reflected ray, let's start with the incident ray. The incident ray, the reflected ray and the normal at the point of contact lie on the same plane. What does it mean is that the ray of light AO, let us consider the incident ray AO, the reflected ray is BO, normal is NO. So all the AO, NO and BO lies on the same plane. They are on the same plane, right? So this is the first law of reflection. So we'll move on to the second law of reflection. The first law basically means that there is no change in the medium. So a ray of light passing through air, let us say this is air medium, the medium is air, which is passing through air, gets reflected from the polished surface at point O and gets reflected back into the same medium, that is air. So there is no change in the medium. There is no change in the medium. There is no change in the medium. Okay. So the second law states that the angle of incidence. What do you mean by the angle of incidence? The angle of incidence is the angle which is between the incident ray and the normal. This angle is known as the angle of incidence. This is known as angle of incidence. And what do you mean by the angle of reflection? The angle between the reflected ray and the normal. This angle is known as angle of reflection. So what does the second law state? The second law states that the angle of incidence is always equal to the angle of reflection in case of regular reflection. So angle of incidence is always equal to the angle of reflection. That means, let's say we denote it by I and denote this by R. So what is I basically? I is the angle AON. So angle AON is nothing but I, and angle BON is nothing but R. So what does it mean? But what does the second law state is that angle AON should always be equal to angle BON. This is what the second law states. Now we'll look at few scenarios. This is normal. So let us discuss. So if the angle of incidence is 30 degree, then what should be the angle of reflection? So according to the second law of reflection, it should also be equal to 30 degrees, right? So now if it is 60 degree, again similar, the angle of reflection also should be 60 degree, right? Now let's say you are given some where it is given that this is the normal, and this angle is given. This is given as 29 degrees. Say it is given 29 degrees. It is asked that find the angle of incidence and the angle of reflection. So we know this is a normal. So what does it make? It is a perpendicular line to the surface. So this whole angle, that is, if we denote it as NO and if we denote as P, so NOP should be 90 degrees because it's a normal line. So what should this angle be? So this angle should be this angle, which is, so what this angle should be angle AON. Angle AON should be 90 minus 29 degrees, right? So it should be 90 minus 29 degrees, that is equals to 61 degrees, right? So angle AON should be 61, which is the angle of incidence, and so naturally the angle of reflection will also be 61 degrees. Now for example, say the angle of of incidence is along the normal. So if this is the normal, the angle of incidence is also along the normal, so it's along the normal. So what is the angle of incidence in this case? The angle of incidence is what? It's 0 degree, because it's along the normal, right? So what should be the angle of reflection? Reflection, it should also be 0 degree. So a ray of light which is passing along the normal will be reflected back in the same direction, right? So it will be reflected back into in the same direction. In other cases where there is some angle of incidence, there will be a change in the angle of reflected ray, but in this case there will be no change in the angle of reflection. So these were few of the important basic topics which needed to be discussed before we move on into the depth of this chapter. So stay tuned for further videos on the chapter light, and if you like this video, please subscribe our channel and share it among your friends.